Hey guys, it's Mr. Schmidt here, and in this video, we're going to look at topic 2.8, the effects of government intervention in markets. This would be pages 77 to 85, and then 477 to 482 in the textbook. So essentially, what we're going to do here is look at different ways the government intervenes in markets, right? Kind of puts their thumb on the scale, and we're going to see that that creates some winners and some losers from doing so. So let's look at the first one, which is called price ceilings. So a price ceiling is a maximum price that can be charged for a product. Price ceilings are designed to help consumers who want to get a lower price. So the ceiling, to be effective or binding, needs to be set below equilibrium in order to help consumers. We're trying to bring the price down. And this is where students get a little confused because you think of the word ceiling, you think of something up high, but when you put it on the graph, you have to set it below equilibrium. So just something to be aware of. The way I remember who price ceilings helps is ceiling starts with a C, consumers starts with a C. So let's see how that looks on a graph. So you notice the price ceiling, to be effective, it's set below equilibrium. And this is for the market for apartments. So I kind of like to think of the TV show Friends, where Monica's apartment is rent controlled, which means that the price of rent is below the equilibrium price and it can't go above that. And because it can't go above the price ceiling, it creates a permanent shortage where the quantity demanded, represented by A2, excuse me, is greater than the quantity supplied, represented by A1. And so therefore we have a shortage that does not disappear. So this creates some winners and losers. Obviously, the loser here, or one of the losers, are sellers because they're now getting a lower price for the apartments than what they were willing to get or what they were able to get before. Another loser, excuse me, are the buyers of apartments that cannot find an apartment because there's a shortage. The ones who can are going to win because they get a lower price if they can find one. So that's the idea of a price ceiling in terms of the graph. Now, in order for a market to be efficient, total surplus must be maximized and there can be no dead weight loss. So, in other words, a market at equilibrium is efficient. When it's not at equilibrium, there's going to be something called dead weight loss, which is a loss of efficiency due to less transactions between buyers and sellers. Because if you look at the graph, you're going to notice here that now the quantity sold in the market is going to be A1 because sellers aren't going to sell A2, even though buyers would like them to. They're now going to sell A1. And so this gap here, the shortage, is a loss of transactions, right? And it's not the whole gap because sellers were only selling right here at the equilibrium quantity before. But from the equilibrium quantity to A1, that gap of transactions, that is a loss of transactions because buyers and sellers over that range of apartments are no longer selling them or buying them. So, with that in mind, let's look at how we model the consumer surplus, producer surplus, and deadweight loss of a price ceiling. So notice that we have our deadweight loss, which is this triangle here, this gray, and it always points to where there isn't any, which is the equilibrium quantity. So basically, the way to draw it is the height of the triangle is going to be the gap in your quantities, and the base is going to be the difference between, in this case, the supply curve and the demand curve. Okay, basically, whatever the quantity is, the sold, that quantity, just draw a line up to the top curve, the demand curve, and that's how you kind of get that area split up. The trapezoid is going to be whoever wins, in this case, consumers, and the smaller triangle is going to be whoever loses, in this case, producers. So area above the price, below the demand curve, area above the supply curve, and below the price, and that's how you split up these areas. For price floors, this is a minimum price that can be charged for a product. They're designed to help firms. Floor starts with an F, firm starts with an F, and they must be set above equilibrium to be binding or effective. And so, again, this is a little backwards from what you think because you think of floor being on the bottom, But for it to work for firms, you got to raise the price. You got to make it higher than it was before. And that's exactly what this graph shows. So P star is our equilibrium price. The price floor is above equilibrium, so it's binding. And notice it creates a surplus. Why? Because the quantity that's going to be sold now is a QD, right? It's not QS. This is how much sellers want to sell, but unfortunately, this is only how much buyers want to buy. And so sellers have to go with that quantity. And so there's a surplus here, which is that gap. And then, of course, we can model the deadweight loss. So once again, go to your quantity, right? Your quantity of the floor. Okay, that's the quantity demanded in this case. And you go straight up to the top curve. And then you got your deadweight loss, which points to where there isn't any equilibrium. The bigger trapezoid, or not the bigger trapezoid, just the trapezoid, that is your producer surplus because they're the ones who win here and consumers lose. And so there is a smaller triangle there. So that's price floors and price ceilings. Now, in terms of this practice, I want you to go ahead, take a look at these two questions, pause the video, and see what you come up with. All right, so correct answers here are going to be B and C. So at equilibrium, consumer surplus is going to be WYZ, the area above the price, which is Y, below the demand curve, and don't go past the quantity sold, which is S, so it's WYZ. If a price floor is set at X, the quantity demanded is going to decrease from OS, which is this distance, to OR. Why? Because first of all, we know the price floor is binding. That's always something you want to look for, because if the price control is not binding, it doesn't work, and therefore you stay at equilibrium. There's going to be no surplus or shortage. So because the price floor is here, the quantity now that's going to be sold is R, so we go from 0S to 0R. Let's talk about taxes to wrap up this video. So this is another way governments can intervene in the market. So an excise tax is a per unit tax on producers. So for things like cigarettes or alcohol. So every time a unit is sold, the producer has to pay a tax. So how do we model that tax? The way to do this is to notice that the tax is the vertical distance between the supply curve and the supply curve affected by the tax. You'll notice here that there is no arrow indicating this curve shift. Why? Because it's not really a curve shift. This is the same supply curve. Remember, all we're changing is the price. And when you change the price, you move along the supply curve. But to show that with a tax, we just show it is kind of a new supply curve, but it's the supply curve affected by the tax. And so you don't actually have to draw this to show it, but it does help, I find, students. So the tax is the vertical distance between the supply curves. In this case, the $2 tax. However, notice here that originally buyers were paying $3 for the product, and now they're paying $4, where the demand curve intersects the supply plus tax curve. So what's interesting here is that sellers don't make buyers pay the full $2 tax, because if they did, then the buyer would be paying $5. So notice here the sellers now receive $2 after the tax. So sellers are paying $1 of the tax, represented by this distance where my cursor is, and then buyers are paying the other dollar of the tax. So the buyers and sellers are splitting the tax equally among them. Now, is that always the case? No. And that gets at this idea of tax incidence, which is what portion of a tax is paid by buyers and what portion is paid by sellers, right? And it's not always 50-50. So how do you determine what portion is paid by who? And you go to the elasticity. The more elastic a curve is, the less of the tax they pay. So for example, the more elastic the demand curve is, the less of the tax the buyer pays, because elastic means the buyer is more sensitive to the price. And so they're going to buy a lot less of the product, which means a lot less tax revenue for the government. The more elastic the supply curve is, the less of the tax the seller pays. The seller is more sensitive to the price. So when there's a tax, they sell a lot less. So they're paying a lot less tax. The opposite is also true, where the more inelastic the demand curve is, the more of the tax the buyer pays because they don't care about the price. Sure, I'll pay the tax. Same thing with supply. So, a little practice question here. If the supply curve is perfectly elastic, what percent of an excise tax would buyers pay? So, go ahead and pause the video and answer the question. So, correct answer here is 100%. Why? Because if sellers are perfectly elastic, that means they only will sell it at one price, and if the tax changes that price, they buy or they sell none, which means the buyers pay all of the tax. Okay, they're paying 100% of the tax. All right, let's model the efficiency of a tax. So notice here we have our deadweight loss, which again, you start with your quantity being sold, you go straight up to the other curve, right? And then it points to where there isn't any. So we have another sideways triangle. Consumer surplus is the area above the price the buyer pays and below the demand curve. Producer surplus area below the price the seller keeps and above the supply curve. And then we have this box that separates them, which is the tax revenue, right? And so this tax revenue goes to the government. And this is how much revenue there is, which would be the area of this box. And then finally, go ahead and pause the video and give these questions a try to see if you get how to find these areas. All right, correct answers are on the screen here. So, consumer surplus before the tax, A, B, C, D. So, this entire area. And then producer surplus, this entire area here. Consumer surplus after the tax is A, producer surplus G, and BCHF for tax revenue, deadweight loss DE, and tax revenue producers pay HF, which is their part of this box. So that's all for this video on the effects of government intervention in markets. Until next time, have a great day.